Usually we get a cue. All right. Well, tonight it's my pleasure to welcome you to the Environmental Commission of Meridian Township, the April meeting, and tonight we have actually a rather large audience given given the usual patterns of this commission. It's my pleasure to sit in for Bill McConnell, who's in Boston right now at a conference. So he couldn't be here, which made him very sad because after we look at the agenda, our first item of business is to hear Jeff Andersen. Oh, whoops, I'm even wrong. The approval of the agenda comes after Jeff. Are you in that much of a hurry? Anyway, okay, the meeting is now officially called to order, and it is 6 minutes after 7. We're running a little behind. But Jeff, you're the first item on the agenda, so Jeff is here to tell us a story about, well, he'll tell us. But
means climate change.
Yes. Words you may be nervous about saying.
We will still say them, but so I want to take, and I know brevity is important here. I'm going to give you an overview of a lengthy discussion, and I want to start with some historical trends here locally and in Michigan. I want to look a little bit at variability, which is a huge issue, a big wild card, it turns out, and then some projections, and then hopefully we can have some discussion with questions. I mentioned I'm going to start with historical. One thing when we discuss climate change is we have to remember that we think of humans as something stable or static, but by nature it's dynamic. It's changing. It has always changed in the past, and it will undoubtedly change in the future. We have roughly, globally, more than 150 years of instrumental records that describe mainly precipitation and temperature. What I'm showing here is a global temperature series back to 1880 through the end of December of last year, and each of these individual points that you see here as the bars are departures from a long-term 100-year average. So the blues are cooler than that one, 1901 through 2000 average. The reds are warmer than that. And what you can see here globally, using the best information we have, and this is not an easy thing to do, but you can see that globally the surface temperatures have risen somewhere on the order of 1.5 degrees to a little bit less than 2 degrees Fahrenheit. Especially since the early part of last century, since about 1910. The debate, 20 years ago, we could have debated perhaps whether or not the Earth, the globe as a whole, was warming, but it's very difficult to do that. The 3 warmest years on record all were the last 3 years, 2014, 2015, 2016. Things are getting warmer, especially since the middle of last century, and you can see that is evident from the graph. Now, here in Michigan, if we put the best data that we have together for the state of Michigan, this is looking at mean annual temperature. Each of the individual dots here is an annual temperature for that given year. Going back to 1895 through the end of last year, what you can see is there are a few similarities, but basically a reminder that different regions of the world behave differently. Most of the world has warmed, especially over the last 50, 60 years, but some places there are even a few that have cooled. But Michigan is one that has warmed, and this is true for most of the upper Midwest and the Great Lakes region. You can see basically a sideways pattern from the beginning of last century, early 1900s, up until the end of the Dust Bowl in 1930s. Then there was a cooling trend of about 1 degree Fahrenheit. That in turn was followed by a warming of about 2 degrees Fahrenheit since about 1980. And it's interesting to note, there's a couple things there of note. One is that the warming has not been uniform around the year. Some seasons have warmed more than others. For us, the largest increases have been in the winter season and at night. Our minimum temperatures are increasing more rapidly than our daytime temperatures, the high temperatures. And that seems a little odd, especially we had 2 very severe winters not too long ago, 2013-14, and then the following winter, 14-15. But even with those, there's still a clear upward trend. All the seasons are warming, but more so in the cool seasons. The other thing to note there, at the end of this series, the last couple decades, there has been a marked increase in variability from year to year. And that's one of the pieces that's a little bit more difficult to decipher, but you can see compared to the 50s and 60s and even the 70s, there's been a great deal more change from year to year. And that's one of the things that climate scientists are very, very interested in, because there are many impacts associated with that. One of the associated impacts with our temperature changes has been a change in seasonality. This is a little bit of a strange graph, a spaghetti graph here. There are 3 series on here, but it's basically looking at the dates of the last freezing temperatures of the spring each year, and that's in green. The first freezing temperatures of the fall are in blue, and then the time in between those 2 dates, the so-called frost-free growing season in between, is in red. And what you can see, again, since about 1980 especially, is that the last freezing temperatures of the spring season are coming earlier, first freezing temperatures of the fall are coming later, and what we have in between is a longer frost-free season. We've looked at this in detail in Michigan. This is a regional plot, but in Michigan it's not symmetrical here. There's been more change in the spring. And so our spring warm-up is occurring now fully 10 days, some cases even more than that, earlier than it did just 30 to 40 years ago. That's a big change. So springs are coming earlier. There have been, of course, exceptions to that, but the long-term trend is certainly in that direction. Arguably the most significant change, I think, in Michigan and the Great Lakes region, and this is also true for most of the upper Midwest, is it's becoming wetter. We have some nice illustration outside today. But if you look here, again, the same time frame, 1895 to 2016, you can see the 30s, the driest, benchmark driest decade on our historical record. Ever since the 1930s, it's become wetter. There have been a few periods where it's a little bit less. But in general, 10 to 15% increase in annual precipitation since the 1930s. That translates to 3 or 4 inches of water, approximately more than we had just 50 years ago. So to put that in perspective, our annual precipitation here locally is somewhere on the order of 33 inches, give or take an inch depending on where you are. And so what we have here now is essentially a whole extra month plus, maybe 6 weeks of extra, and that's even warm season precipitation, because we have more precip climatologically in the warm season than we do in the cold season. So we've got a lot of extra water to work with that we didn't have before. That's important for many, many reasons. I'll show you just a couple in a second. So how is it getting wetter? Well, there's 2 reasons for that. One is that we have more wet days now than we did before, so more days with measurable precipitation. The other is, of course, you have more precipitation per event. We're having more extreme events, and that's what this graph depicts here. Once again, this is actually for Michigan, Wisconsin, and Minnesota collectively, but this is looking at the, daily precipitation events way in the tail of the distribution, very, very heavy events, and how they've changed. And of course, you can see an increase. This is true for 1-inch events per day, 2-inch events. All of those have increased significantly here, especially over the last few decades. So that increase, again, that you saw is due to both more extreme events plus more wet days. A couple of pieces of note here about variability. I mentioned that just a second ago, and extremes, but the issue here is that even though climatic extremes are relatively uncommon, they're rare, they many times account for a majority, or at least a large portion of impacts on our both human and natural systems. It's important to look at them, and we've had our share over the last several years. I've mentioned a few here. If you remember the crazy March of 2012, the heat wave, which was followed by the worst drought in over 25 years. And that, in turn, was followed by the second wettest year on record in 2013. The winters that we'd like to forget, or many people would like to forget, unless you're in the winter outdoor recreation business. Terrible winters, 2013-14. And then, of course, was followed by, record warm December 2015. We had the 5th warmest winter 2016 now, this past year. It would have been even higher than that, but December was relatively normal. So we've had a great deal of extremes here to do, to experience or observe locally. One of the differences here that's very, very, I think, noteworthy is because of the extra precipitation, the frequency and severity of drought here in the Great Lakes is decreasing. And that's what this particular graph depicts. Greens are surpluses, are abnormally wet periods. The brown, yellow color here are drought years. You can see once again the 1930s just stands out above everything else in terms of droughts. There were some severe droughts also the late 50s, early 60s. But look what happens over time. There's more and more green. And so we're translating directly into a decrease in drought. The 2012 drought, interestingly enough, is the last one there. Look at that. I mean, compared to some of what's occurred in previous decades, and that was a huge economic impact in the state, but it's, at least by climatological terms, it was relatively minor. So that's one impact. And of course, you can look at that certainly as a positive. There's pluses and minuses to all these. But that's one. Here's another one in terms of extreme minimum temperatures in the cold season, in the winter. This is a change in the plant hardiness zone index. And you see on the bottom here the old map back taken from 1951 through 1980 data, and then the update, which was just published a couple years ago. And because of the warming of our winter temperatures, we now have typically a full zone, needs for less hardy crops or plants. And so almost all the U.S. is the same way. We've all, again, it's less stressful during the winter. That's another impact. This one is an interesting one as well. This is the number of major weather-related disasters in the United States. That's what the large graph is here between 1980 and 2016. The inset over on the top is a similar graph, but it's for globally. And the most common billion-dollar weather disasters here in the U.S., of course, are, not surprisingly, are tropical cyclones, hurricanes, but drought also plays a major role here. Heavy flooding rain events. We've got a couple winter storms in there, but what you can see and what the point is here, you look at that and there's an increase, at least in the number of these disasters. And note that they are all inflation adjusted, so it's all the same dollars, but we have an increase in the events. The real interesting point is that the actual numbers of these events have not increased. And so when you ask yourself, well, if the events themselves, severe weather, for example, has not increased over the past time, why do we have more of these events? And the answer, of course, is that we have more things in the way. We're more vulnerable. And I think that's one of the points we have to look in the mirror occasionally. And this is not a trend that we should be we should be concerned about, I think. And this is true in other parts of the world as well, not just the United States. Want to finish up with some projections for the future, and this is a difficult thing to do, but the science is getting better and better, we think a weather forecast for the next 48 to 60 hours is difficult. It's a whole different world to try to project out decades in the future. Many economic assumptions are necessary. There are societal assumptions about a society, efficiencies. There's all sorts of things that have to be made, and so what we have collectively with the latest projections is this graph right here for Michigan. These are projected changes in mean annual temperature out through the end of this century. And you can see, depending on whether, emissions of greenhouse gases, there are a number of scenarios on the far right, but they range anywhere from about 2 degrees Fahrenheit to more than 13 or 14 degrees Fahrenheit. Again, mean annual temperature. That's a huge increase. The higher scenarios are associated with the higher emission scenarios. And you can see there's quite a bit of variability there, but all of them suggest warmer climate in the future for Michigan, without any exceptions. It's just a matter of what assumptions are made. So the far left, if you're interested, that's the actually observed series, and then what the climate models have said about our past. And you can see the climate models have done actually a fairly decent job of depicting conditions here in the Great Lakes. In terms of temperature and looking at the Great Lakes region itself, or the upper Midwest here, increases in the number of days above 95, and essentially a shift in terms of heating versus cooling. So we would have less heating needs in the cold season, but we'd need more cooling costs, so we'd have some trade-off between those two. an increase in the frost-free season. And it's interesting to note, and you probably have already thought about this, but some of our observed trends over the last couple decades are in general agreement with these projections. That could be coincidental, but I think it's important to note. In terms of precipitation, it's a little bit less clear. Some of the projections suggest wetter overall conditions in the distant future. A few say drier. The majority do say wetter, though. But there's an important, I guess, caveat there, and that is that many of the projections suggest that even if we have increases in precipitation, most of it occurs during the cool season, and we'd have more liquid precipitation than snowfall, with not many changes during the warm season. And of course, those who think about that are natural vegetation, agricultural industry, all those plants, communities depend on water during the warm season, so this is a fairly major red flag. The number of heavy precipitation events is projected to increase, and I think maybe one of the most important things to note about this is not all, but some of the projections suggest that precipitation would become more erratic, and that's a word I wish that the climate, the projections would use, because it's really what it describes. And we've heard statements from the IPCC like we're likely to see both more floods and more droughts. And when most people think about that, they say, well, that doesn't make any sense. There is one physical way, though, that can happen, and of course that's, yes, we have more precipitation, but it falls on fewer days. And so we do have more periods without precipitation. That's again, that for most systems, both natural and human, that's not a positive thing. That's actually a very negative thing. And so that is where that statement comes from. And it's something, there's less confidence about that, but that is one of the pieces of the projection. And so just to summarize, this is a very brief overview here. Warmer and wetter has recent historical trends. But not all of it seasonally, more warming in the cool seasons. Precipitation, I didn't mention this, but it's more uniform. The increases in precipitation have been more uniform across the seasons. I didn't talk a lot about the Great Lakes, but they've been warming up as well. Less ice, both less amount of ice and less time, ice coverage on the lakes. The projections for the future are in general agreement. They're also saying warmer and maybe a little bit wetter, but the caveat there again, even with additional precipitation, probably in the off-season, and that would change our hydrology a little bit. And with these changes, warmer and wetter, note that you've got a whole bag of both positive and negative impacts, depending on your sector or what type of economic activity you're talking about. Many of these, though, even for some of the beneficial impacts, agriculture would be one that would likely benefit, at least for the short term, with this. And that's some research that I do. But in the distant future, the changes become a little bit too large, unless there's major changes in technology, and hopefully there would be. But the last parts of this, and this is a sort of common sense, the climate is changing, and it means that we have to be more dynamic in terms of our planning and thinking ahead. And one of the wild cards still, one of the things that these projections do not do well are these extremes. And that's one of the reasons I talked about it. Yes, we historically we can see these things and see changes in them, but because of the scales of the model projections and so forth, they just don't do very well. There's thought that some of them may increase in the future, but it's low confidence at this point. So more research is needed certainly there. And with that, I'll finish up. Hopefully, I haven't gone too long or too far over. But any questions, thoughts, comments?
Jeff, I have a question for you.
Sure.
Of necessity, probably scientists are conservative, and I've read at times that actually things are happening quicker than people originally predicted.
Right.
And I'm wondering if that's true from what you know, and should we expect things to actually be even worse than what is being predicted, or is that...
Two thoughts, and they're different. I think they're different scales and time frame. One is the large scale and sort of the big picture. And I mentioned at the outset, we know that the global climate has changed dramatically. Here locally, we've had climate vary from tropical when the tectonic plate that North America and Michigan are on was much closer to the equator, to glacial, and then everything in between. So we've been all over the place. So we know that changes. What is concerning about this and what we're talking about here is the time. And we know that these changes take place, but typically it's over tens and hundreds of thousands of years or longer that they take. We're talking now about the same magnitude of change, but in decades. And that has happened. We've had meteor impacts and other cataclysmic events that have caused but that's rare. And so the real problem itself is really adapting to this rapid change. That's unusual, and that's some of the, at least for the whole issue, that's one of the biggest problems. So that's the big picture. And specific example of what you're talking about, though, one comes to mind is the melting of ice on the planet, specifically Greenland and parts of the polar ice cap. That is by most measures much faster than had been anticipated. That's one example. There are other pieces of that, but that's another symptom associated with this rapid warming. And if you look at this globally, the largest changes in temperature have occurred at the high latitudes on continents, like in the northern North America and Eurasia on the other side of the world. There are relatively fewer changes where you have all sorts of water, the southern hemisphere with the oceans. But that's also what the climate projections for the future suggest the same thing. The largest changes would be in the high latitudes of the northern hemisphere. And so, again, that's where we're seeing some of these large changes. And again, you look at sea level increase 30 centimeters over the last century, and that's a huge issue as well. Fortunately, not so much for us here in Michigan, but it will be indirectly because there's a large economic price to pay to prepare and to deal with increasing sea level, which is already happening in many parts of the world. So we don't see it here directly, but economically it would impact us here as well.
So, Jeff, one question I would have, and I think you kind of have alluded to it a little bit in preparing for these changes that are already occurring.
Yeah.
And, an issue like this is such large magnitude. It's obviously global in nature. So, when we sit in a local government setting, I was just curious if you had any thoughts on what a local government can do to either prepare or try to limit the effect that it has given its smaller size.
And this is a really good question. And I think one of the positive things, this is a challenging topic or issue. In Michigan, we have it pretty good. We have a relatively low number of weather, climate-related disasters here compared to many other parts of the world and even other parts of the U.S. as well. I think if I had to, my opinion, the one that makes has the biggest potential impact for us and the one we really need to look at are these heavy rain events. I started with the image on the front of the Detroit area, the huge floods there a couple years ago. That had an economic impact depending on who you look at. It certainly hundreds of millions, if not $1 billion, one event that did that. And so I think for us, if we look ahead at what we really have to look at, it's that infrastructure and how we deal with excess water. That's a big, big deal. And as our infrastructure, of course, ages and changes, it's even more compelling reason we have to. And it's not an easy one because, of course, there's an economic cost to that. But if I had to put on the top, that would probably be at the top of my list, at least in the one we have to pay attention to. Some of these other impacts, milder winters, most people, again, there are some industries that do, but many people would complain about that. We have more water for the agricultural industry. That's a good thing. We can show benefits already, but some of those are short-lived and you can have too much of a good thing. But these flooding rain events, I think, are a real challenge, and we have already seen examples of this in the not-too-recent past. Yeah,
so that raises a really important reference point, which is that you've got these graphs with sort of what is the reference point? Where do you set the zero? And of course that's, as an academic, I'm used to doing that all the time. But as somebody here representing the township, or at least thinking about the future of the township, one of the reference points is the definition of a 100-year flood, and every every house, every construction project, every consideration of wetlands, et cetera, ultimately has some reference to those kinds of numbers. And I'm just wondering, are we seeing in certain areas people actually revising the reference points themselves? And if so, is there any sort of systematization of how to approach those things?
Well, as a good academic, I brought extra material.
Good, of course.
So,
no, usually
just
you
in
have
case, you never
about
know.
200 slides after the 20 that you actually.
I've got a couple extra, but this one is and it's a great question, but I think it tells a story. So this is a chart of this is for the Lansing area, and these are 2, 10, 50, and 100-year, 24-hour, so one-day events. And there's a couple lessons here, but the first one is the top line there, the TP40, that's technical paper 40. These were the legal standards back for decades. But the data that derived those numbers, they used to derive those numbers, dates all the way back to the 30s, 40s, and 50s of last century.
Which were especially drought.
Right. So think about what you've just seen. And so if you look at that, the 100-year event, daily event, 4.8 inches. And that's what the legal standard was for Lansing for decades. Up until recently, there was another study done by Jim Angel at the Midwest Regional Climate Center in Champaign, Illinois. That had a larger data set, and you can see with theirs, that took data up through the 90s. It increased up to 5.25 inches. And now we have a new tool in this in the toolbox, and that's NOAA Atlas 14, which takes basically everything up through 2013. And look what's happened to the number here. So we've had a change here on the order maybe 15% or so, depending on. So these things are changing. The tough part, and this gets to the statistics, and I have students ask me this, well, how can you come up? They have 500-year events and 1,000-year events as well. And of course, the question, well, you said you only had 150 years of data. And that is a big challenge, and there's some statistical assumptions that go into that. I personally am not a big fan of that, and the major reason I'm not a big fan is because it's not stationary. And as you know, we're shooting at a moving target, and those pieces of that distribution at the very end, they're the first ones to go. They're the ones that are going to change rapidly. So, but there's no question, unmistakably, these numbers are getting larger. And so, again, this frequency and severity of these heavy rain events is increasing, especially over the last 50 years. And
so
that's what you see here.
How many floods have we had in the last 100 years?
Well, more than what those statistics would probably suggest. And I get it's a strange world, but many times it's required by law. The engineers, the architects say we have to have a number. What is that? We have to conform to this number, and that's what it is. However, we also have to remember that there's and actually NOAA Atlas 14 does have confidence intervals now for that reason. But if you look at the confidence intervals for the 1 in 500-year event, they're way out there because there is a lot of more uncertainty.
Does NOAA Atlas 14 have the power of law?
I believe it does now. It's a federal funded project. I think I'm not positive, but I think that it does. That is, in my knowledge, that's used as a legal standard.
So those reference points sort of automatically get brought to us as we
right. And I hear a lot when I have phone calls about this as a state climatologist, and many times I'm asked about the 20-year event. If for legal reasons, it depends on the application, but MDOT and there are other organizations that have very stringent rules and requirements on how these things are built, and most of them are less than 100 years. At least the ones that I work with on a regular basis. But almost all of these events, as you can see, have increased in magnitude.
Well, part of my reason for asking is personal. I'm actually from Massachusetts, and in Massachusetts, hunks of bedrock that I've played on since I was a baby, unquestionably have 30 centimeters is about right. It's a lot. Yeah. High tide is in a whole different place than it used to be, and for people who don't have that reference point, it's easy to sort of say, well, it's just a little wetter now or something like that. But that's a well-defined geometrical measure to me of change that's happened in my relatively short lifetime.
And there's very, very strong, observations and evidence to back that up.
Right.
About it's different and a little bit different in some places, but it's unmistakably higher.
Right.
Other
questions?
Thoughts or questions? Yes.
Oh, sure, please.
Thank you for coming tonight.
Oh, you're welcome. You're welcome.
I love hearing confirmation of what I've observed over the last 40 years. I'm a sugar farmer here in Meridian Township, and so I have to pay very strict attention to the freezing temperature in the first
Beets? Sugar beets or?
maple.
Oh, me. I should know better.
The time of the first sap day has changed from, it used to be, and all the sugar farmers around here will tell you, it used to be March 15th. And we've had so many recently that have
February.
In
January even?
January. But the average is 3 weeks greater than it used to be in the 40 years I've been doing it. And I just got, now I don't do it anymore, but now I'm a snowbird. I just got back from Florida yesterday, and boy, they are having sewage backups on every high tide because of the rise in the sea level. And it's a serious problem, and talk about infrastructure adjustments, they're not going to be able to withstand that in coming years. And when you think about the problems of immigration, we're going to have immigration from our own nation, from the coast to Michigan. So we have to get, not only with our infrastructure preparation, but our people accommodation planning. I was a planning commissioner here for over 25 years, and we also had a much higher rate of 100-year floods, like every 3 or 4 years.
That's why I was asking.
So all our standards for planning in that regard have to be adjusted as well. And I just want to thank all of you for serving. Way back in the 1980s, I was a township board member and started a wetland protection ordinance, which grew into your commission. And I just congratulate all of you for carrying on the work I slaved away at way back then. Thank you very much.
Well, thank
We're grateful to you. Yeah.
Any other?
I have lots of questions, but maybe I'll buttonhole you afterwards because there's so many. So, I mean, you talked about economic impacts of disastrous events, but there are other obvious things. For example, out in the sort of northern west, it's very clear that things like the pine borer beetles are moving north and so forth because we don't have the coldness and the periods of cold that will kill them or will stop them anyway. So in that same sense, of course, we have lots of various types of invasive
exotics,
plants and animals here, and I'm just wondering what's and even people have even talked about tropical diseases, or at least warmer weather diseases in terms of human pathogens coming further north as mosquitoes of different types move their territories. And so, as you said, these things are all moving targets, and I guess I'm really wondering how does a civilian parse all of the variation that is without panicking, but just trying to remain informed so that you can anticipate exactly as we were just hearing.
The examples about the exotic species, I think, are a really, really pointed one. But in research that I do involving agriculture and these changes, the huge wild card, and it's a complete game changer. It's great for these crops if they have more water, it's warmer, they have a longer growing season, more carbon dioxide. That's another factor we haven't even talked about. That's wonderful, but that's if you keep everything constant. And of course, you never can, you never do. And you have to look at things like weeds. If it's more favorable for a soybean plant or a wheat plant, well, they're going to be weeds that are twice as happy, or more insects that we haven't dealt with before, diseases. These are all game changers, and there's much, much less known about them, and the same is true for all these, for some of the other topics that you've mentioned. So the federal government, and actually state governments too, have developed groups that are created to act very, very quickly for these new emerging problems. The exotic species are one that come to mind, and maybe at least we have to think about that. Nimble, ready to roll with a wide spectrum of possible tasks or responsibilities. Again, we're looking at a moving system, and it's how it behaves is going to surprise us on occasion. So that's a tough one. To build, it's again, how do you build infrastructure with this? That's a real challenge to do. And unfortunately for us, given the trends that we have, all the engineers and the design people, it's not linear. As you have to design more capacity, it's exponential, the cost of these things, and it's a real challenge. How do we do that? And I don't know if anybody knows the answer to that, unfortunately.
Well, thank you very much. That was
my pleasure. Thank you. And if well, we can ever provide or help with input information or data of any, we definitely have a fairly complete, at least where we've been, and we also have projections of at least what's anticipated ahead. But if we can help in any way, let me know.
Are you willing to share your slides, or are your slides
Absolutely.
available on the website of your?
Well, it's on your desktop here, so you're welcome to use those. That's fine.
Okay.
Some of the ones that I've borrowed from various places are referenced, but some of them are mine. So it's
okay.
You're welcome to use those, so if you like.
Okay, that would be great. Thank you.
Thank you.
Any other questions from our audience? Okay. All right. Thank you so much.
My pleasure.